Hey, this is Mr. Ng going over your Math 5 quiz number 15 corrections, Chapter 5, Section 1 to 5.5, taken on March 26, 2018. This was out of 34 points. How I graded this was basically the person who was stapled on the front, I graded the front side, and I added to the person on whoever had the back side and added your scores together. It is possible you lost a point for not boxing your answers on the free response on the backside where it says box your answers, and then if your work is messy, not using ruler, I can't read your writing. Let's go over questions. Number 1. Question number 1, multiple choice. Find the function f whose graph is given below. Or here's our graph. I noticed a couple of things. The arrows are pointing in different directions. So this would be a odd function. It's an odd function because the arrows are in different directions. You also have a leading coefficient that's a negative. The reason why is that is because normally it starts down, ends up. And how do I know that? Think about x to the first. X to the first would have been a straight line in this direction, but because the leading coefficient is negative, it's going to go starts up, ends down. The other way I knew that was a fifth power, you can count the number of zeros. 1, 2, 3, 4, and then that's actually 5. That's a double root there because there's the bounds for the kiss. Well, how do you get an equation? So I know my leading coefficient is negative, so I can eliminate D. And I can also eliminate A, so my choices are just B and C. So here, it gives you a value of x equals -1. Now, if you need to set this equal to 0, what you're going to do is you're going to add 1 to both sides, and you get this factor called x plus 1 equals 0. And because it's shooting through, or just passing through the x-axis, it's an odd. So shoot-throughs are odd multiplicity right there, that's a 1. Then I get 0, so x is equal to 0. Or some of you guys think of that as x minus 0 equals 0. Here I have another shoot through at 1, so x equals 1, and I have to set it equal to 0. I subtract 1 from both sides, I get x minus 1 as my factor. Remember, that's to the first power because it's a shoot through. And then here, this is x equals positive 2, and then you subtract 2 to both sides to get x minus 2 equals 0. And it's a multiplicity of 2 because this is a even multiplicity. That number's even to kiss. So my answer would be choice B. This one is incorrect because if you take all the x's, x, and then x squared, it gives you x to the 5th, which I think my problem is wrong. Let's think. X squared times x is x to the 3rd, x to the 4th. So this would be an even pointing down. So the correct answer is C. Make sure you have C, not B. I'll have to go back and check my multiple choice. Question number 2. See if I can zoom in a little bit. $77. Alright, so this problem says match the function with its graph by writing a letter to the blank. So each of these, I look at my problem here, I realize I'm starting down, ending up, so that means it's an odd. My leading coefficient is positive. I'm looking for ones that are odd. These are these two. This one's the only one that's positive. Another way you know that it's positive, the answer is number 3 matches graph A because you can count the x-intercepts 1, 2, 3, 4, 5. So there are 5 x-intercepts, and then the extremas 1, 2, 3, 4. Extremas is degree minus 1. So if we have 4 extremas, that means we must have a degree of 5. Graph B starting both up, so that's an even. They're both up, so the leading coefficient is positive. Remember, x squared, they both start positive. The only one that has an even that's positive would be choice 2. And then again, you can look at the x-intercept. Remember, when it bounces here, that's actually 2 x-intercepts or 2 roots. So that's 2, 4, 6. That'd be 6 roots. And then you can also do the extremas. 1, 2, 3, 4, 5. So 6 minus 1 gives you 5 extremas, which I just counted. Graph C, I have starting up, ending down. That is an odd, leading coefficient negative. That would be choice equation number 1, so 1C. Again, you can also tell by the extrema, 1, 2, so that would be the degree minus 1 equals the extrema, so this one, and then you can also do by the x-intercepts. Remember the x-intercepts, it's a max, it's not just equal to, so 1, 2, 3 has a max of 3 x-intercepts. And the last graph, even, because they starts down, ends down, and the leading coefficient is negative. And the only one that isn't even and negative would be choice 4, which would be D. Those were 1 point apiece. Question number 3. This is not multiple choice. You just need to circle the correct answer. So I have a graph here. I want it to look like a roller coaster. And you're starting down and then you're ending up. This is an odd. Remember, if you don't know which one it is, just look at your easiest graphs. X to the first. It's a positive leading coefficient. It starts down, ends up, and it would be a negative slope or negative linear equation if it starts up, ends down. So this is a positive odd. So our degree is odd. The leading coefficient is positive. When you think of the end behavior, it says the left side, so go to the left side. So as the sentence that you should be thinking of is as x approaches the negative infinity, negative numbers, the graph is going down, so that would be that choice, or f of x, or the y values approach negative numbers. Right side, as you go to the right side, that would be as x approaches positive infinity. So on the x-axis, the values are getting positive, bigger, then the f of x values are going up, so that would be positive, so the up. And the last question on the backside is just true or false. So here's your graph. It wants to know if there's any real roots. And a real roots in green, I've highlighted, means it touches the x-axis. So the graph does not touch this graph right here, this parabola. We're assuming it's a parabola. Hopefully it doesn't do any other polynomial functions, but it doesn't touch the x-axis, so there are no or zero real roots. So that would be true here, and then false, and then false. Here, the word imaginary roots, I put here for the vertex. So notice how it's off the x-axis. That's how you know there is an imaginary. So this is an imaginary, but the question is how many? The answer is 2. Remember, it's kind of like a kiss or a bounce. And so here this represents a double imaginary root, or 2 imaginary roots. That's why this one is true. 0 imaginary roots means that it would be touching the x-axis, either bouncing or kissing or shooting through. And then this answer is false because complex solutions or imaginary roots come in pairs. They come in evens, so it must be an even. So the reason why this one's wrong is if you look at our graph and this is quadratic, you should have 2 x-intercepts, or 2 roots. But your 2 roots here don't cross the x-axis, therefore they are 2 imaginary roots. That's 2, or if it was like this graph, this would be 0 imaginary roots. So you're going from 0 to 2. Notice how there's no other scenario, so it's either 0 or 2 imaginary roots. So 1 point apiece, and then the backside was worth 18. We go on to the backside. Free response, make sure to show all your work and box your answers. If the person's paper on the backside has the word box circled, that means back up on here, you probably lost a point for not box your answers, or if it looks messy, you also got that -1. Number 5, sketch a set. A set is like a pair of functions whose product, you have to multiply, builds a cubic function with a given characteristics. Then explain your reasoning. So here are my zeros. This is really across the x-axis. X is equal to -2, x equals +2, and x equals 3. And then from there, you can do a couple of things. I decided to do a quadratic through the blue and the green. You could have done a quadratic through the green and orange. You could have done 3 linear, so I did a quadratic. Where's my explanation? So explain your reasoning. A linear times a quadratic equals a cubic. So you got 2 points if you drew some cubic function. That would have been incorrect because you're looking for a set or sets of functions. When you multiply them, or as a product, equals a cubic, not just drawing a cubic function. So here, if you just drew them through those colored symbols, then you got 2 points and the rest of it's wrong. I give you 3 points if you drew a correct graph, maybe such as 3 linears, but then you didn't give me an explanation. Question number 6. Number 6 says, sketch the graph of the cubic function that is the product of the functions below. So we need to sketch a graph. And based off of our 3 here, I need to get a cubic function, then determine the product of the functions algebraically. So here, these are called factors. X plus 2. And then what I'm going to do is I'm going to use the 0 product rule. So I'm going to set the factors equal to 0. And when I do that, I get x equals -2, x equals -1, and x equals +3. So -2 right there. Pink is +1. Blah, blah, blah. That should be a +1. +1 right there, which is right there. And then x equals +3. Okay, from what I did there is then we did in class, we drew these dotted lines through the x-intercepts, through those dots. So the graph has to go through those points. The next thing is some tips that we should know is that we have to do the products of these. So what I did is just to the left side of this blue dotted line, I drew a yellow line. And the reason why I did that is look intersections. At the intersection of here, here, and here, I'm noticing if it's below or above the x-axis. So if it's below the y-axis, this is a negative times a negative, which is a positive, and a positive times a negative leads me to, a negative. And then this yellow line, I'm looking at the black intersections there. So this is above the x-axis, so this would be a positive times a negative, which is a negative, and a negative times a negative is a positive. And then I did, so there's my pink line, and then I did in between, so these yellow lines are between, inside those intervals. I'm looking at my yellow line where the intersection is, so I have a positive times a negative. Positive times a positive times a negative gives me a negative. If you get stuck on that, just use your regular calculator, and you can just use +1 times +1 times a -1. And then over here, same thing onto the right side. I have on my yellow line, I just drew anything to the right side of the green. So I have a positive times a positive times a positive gives me a positive. And what that does, it helps me draw the graph. So a couple of things you could have noticed. There is no negative sign here, so you have a positive leading coefficient. The second clue it tells you, so that would start down and up. And remember, it's just x times x times x gives me x to the third. And you verify the algebraic, I'll show you below in a second. So if I know that in this interval here, left of the blue line should be a negative, that means I'm starting down. The graph is below the x-axis. And if it's a positive, that means it has to go above. Remember, I have to go through the x-intercepts. And I know I have to go below because this interval is a negative. And at the green, I have to go through the green. And then it tells me it's going to be a positive, so you go back up. And this is what your graph kind of looks like. The maximums can be higher and the minimums can be lower, but that's generally what our graph looks like. You also know the multiplicity of ones on these, so you know that you have to shoot through in all of those. All right. Then determine the product of the functions algebraically. So basically, I'm just taking the binomial times a binomial times a binomial. And when I do that, x minus 1 times x plus 2, so x times x is x squared, 2x, negative 1x, negative 2. Combine like terms, so I have x squared. This becomes positive x and negative 2. And then you're multiplying that just by x minus 3, so that's x cubed, x squared, negative 2x, negative 3x squared, negative 3x, and positive 6. So here's my answer, x cubed minus 2x squared minus 5x plus 6. If you just got this correct and your graph is completely wrong, I give you 2 points. Let's say you got this wrong. And let's say in your graph, you just put the dots there at the correct x-intercept, I give you 2 points when your graph is wrong. In order to get 4 points, you had a correct graph and also correct algebraically. All right, question number 7 says write 2 different cubic functions as a product of functions with the given characteristics. Hint. So I added this. This came from your worksheet. A lot of these problems did come from your worksheets or what we done in class. Hint, keep as factors and don't multiply. So how do you get as a product of functions? So my end result is that I can multiply them to get a cubic function, but it tells me don't multiply, just put them as factors. Well, how do you get factors? This is where it crosses the x-axis, so a -3 would be something like over here. Well, I need a factor. What you do is you set it equal to 0, or you want to make it equal to 0. So here in this case, I'm going to add 3, so my factor is x plus 3. X equals 0 where it's already there, so you can just leave it here, or some of you guys like to write x minus 0 and in parentheses. That would be okay. This one is x equals 1, so you're going to have to subtract it and you get x minus 1. X minus 1 is the factor. So here's an example. A lot of students here got a point off, or not a point off, but not boxing your answers. So remember, my hint was you can either double or triple one of these or to get your second different cubic function. So generally this is the first answer that most students had. If you wrote something like all of this and you repeated it and wrote x minus 0, that's basically the same thing, so that doesn't count. So here you can double that one. Here's an example of doubling the first one, just taking this and multiplying by 2. Now, if you wrote the 2 on the outside, I think I gave you credit, but it's better if you had it in the inside, because then you could just take out the greatest common factor. Or an x minus 1, you can triple it by just making it 3. 3 times x, 3 times -1 gives you this. So 2 points if you got one factor correct. Meaning like the other 2 were wrong, and then 3 points if you had like, say, something like f of x here. And then you also got 3 points if they were all correct, but then your signs were wrong. So again, don't just put that in here and write x minus 3 equals 0. That'd be incorrect. Right, your last question. Zoom out here, let's see. Sketch the graph whose product builds a quartic function with the given characteristics. So we're trying to build a quartic. We're not drawing a quartic, because it could have just said sketch a quartic function with the given characteristics. It says sketch the graph whose product, means we have to multiply them to build a quartic. So the two imaginary roots are my a parabola coming from a quadratic graph, or quadratic function that doesn't touch the x-axis. So you could have put one opening down or facing up. My explanation for that, the two imaginary roots come from the quadratic function whose equation is y equals -x squared minus 6. Now you didn't have to give me the equation, but you should have noted that it can't touch the x-axis. Now the second one, where it says zeros, these are the real zeros, which means it has to cross these, and notice how it doesn't tell us about multiplicity, so it should just shoot through. So I drew a linear at x equals -3 and one that goes through x equals 2, or you could have drawn a parabola going through there. My explanation for that one is the two zeros of x equals 2 and x equals -3 come from two linears whose x-intercepts are -3, 0, and 2, 0. So how I awarded points for that one, I said if you have the wrong graph, that's what the G stands for, and explanation, but you drew like some kind of graph, something goes through at least two of these x-intercepts, I gave you 2 points. I gave you 3 points if your graph was correct, but your explanation was incorrect. And of course you got full credit if you had all of them. That side was worth 16 points. I hope this was helpful for you to study for your tests. Have a good day.